Question 1. In a modern context of hydronic systems used in multi-story commercial buildings, what is the primary reason variable speed pumping strategies are preferred over constant speed designs? A. To reduce the possibility of air entrainment in the system. B. To maintain a consistent return water temperature under all load conditions. C. To decrease the energy consumption associated with part load operations. D. To eliminate the need for differential pressure control valves. Answer. Correct answer, C. Explanation. Variable speed pumping reduces energy usage during part load conditions by adjusting flow based on demand, complying with ASHRAE 90.1 energy performance standards. Constant speed pumps waste energy when full flow is not needed, while air entrainment, A. Temperature stability, B. And valve requirements, D. Are secondary considerations. Energy optimization is the key driver behind variable speed adoption. Question 2. Given the circumstances, Mr. Morales is managing a rooftop unit retrofit in a 30-year-old retail store. The unit's blower motor has been replaced with an ECM electronically commutated motor to improve efficiency. Shortly after installation, multiple comfort complaints arise due to uneven airflow. What is the most appropriate diagnostic step he should take next? A. Rebalance the duct system based on new airflow profiles. B. Revert the motor to a traditional PSC design. C. Reduce the fan speed using the dip switch panel. D. Replace the blower wheel with a larger diameter model. Answer. Correct answer. A. Explanation. Switching to ECMs changes the fan curve and airflow delivery, requiring system rebalance. ASHRAE standard 111 supports rebalancing after component retrofits. Options B, C, and D address symptoms but not root cause. Without rebalancing, issues like hot-cold spots persist. Balancing ensures optimal comfort and system performance post-retrofit. Question 3. When evaluating the merits of an air distribution system in a large office building, which of the following best explains why turning vanes in elbows and T's are crucial for maintaining static pressure efficiency? A. They ensure directional airflow and prevent coil freeze-up. B. They reduce turbulence and pressure drop at duct transitions. C. They enhance velocity recovery and improve damper modulation. D. They eliminate the need for upstream straight duct sections. Answer. Correct answer, B. Explanation. Turning vanes guide airflow smoothly through duct bends, reducing turbulence and static pressure loss per SMACNA duct design standards. Coil freeze-up, A, and damper modulation, C, are unrelated. Option D is incorrect. Turning vanes don't replace the need for straight duct runs, especially before airflow measuring devices. Question 4. Illustrated by a recent audit, a data center cooling system using a chilled water loop consistently operates at 4 neg rather than the designed 10 neg. What is the most likely cause of this deviation? A. The chiller is undersized for the actual cooling load. B. Two-way control valves at air handlers are stuck open. C. The system is overcharged with refrigerant. D. The chilled water pump is operating at below rated speed. Answer. Correct answer, B. Explanation. Low DT syndrome often results from control valves not modulating properly, keeping chilled water flow unnecessarily high and preventing optimal heat exchange. ASHRAE 90.1 and data center best practices emphasize DT optimization for efficiency. Options A, C, and D affect load or flow but are less common causes. Question 5. Throughout the course of refrigerant recovery from a low-pressure centrifugal chiller, Mr. Delgado notices that vacuum levels stall despite ongoing recovery efforts. Which of the following should be verified first? A. Presence of non-condensables within the evaporator barrel. B. The moisture content in the oil sump. C. Whether the purge unit is functioning properly. D. Operation of the recovery cylinder's internal flow switch. Answer. Correct answer, C. Explanation. Stalled vacuum is often caused by non-condensables that accumulate due to poor purge unit performance. EPA 608 rules require purging to be functional before final evacuation. Options A and B relate to system integrity but don't typically halt vacuum progress. Option D relates to storage, not system evacuation. Question 6. The underlying principle of compressor staging in large HVAC systems is designed to improve what operational characteristic A. Minimize the refrigerant migration to the condenser. B. Match system capacity with varying thermal loads. C. Reduce the superheat across the evaporator. D. Decrease the suction pressure drop across the piping. Answer. Correct answer. B. Explanation. Staging compressors allows partial capacity operation under low load conditions, matching output to demand. Vital for energy efficiency and comfort. Refer to ASHRAE fundamentals and DOE commercial HVAC efficiency requirements. Superheat control, C. Pressure drop, D. And refrigerant migration are important, but not the primary purpose of staging. Question 7. In response to a newly discovered refrigerant leak a walk-in freezer Ista Singh instructs his team to use nitrogen during the leak check. Why must a pressure relief device always be included in this procedure? A. To meet OSHA requirements for high-pressure testing environments. B. To allow faster identification of leaks through hissing sounds. C. To ensure complete purging of oxygen from the system. D. To prevent overpressurization and system damage. Answer. Correct answer. D. Explanation. Nitrogen leak testing without a relief valve risks exceeding pressure limits, violating Section 7.2 of US B.5 and EPA 608 safety protocols. Overpressurization can cause rupture or injury. Sound detection, B. Oxygen purging, C. And OSHA compliance, A. A secondary. Safety through pressure control is paramount. Question 8. From a practical standpoint, which scenario most accurately demonstrates poor system design in a rooftop packaged HVAC unit? A. Return air temperature fluctuates within 2 degrees of set point. B. The compressor cycles more than 8 times per hour under moderate load. C. The outdoor air damp remains partially open during unoccupied hours. D. Discharge air velocity exceeds 1500 fpm at the register. Answer. Correct answer. B. Explanation. Excessive compressor cycling indicates short cycling. Key sign of improper load matching, oversizing, or faulty controls, reducing system life and efficiency. According to RE&OES specs, compressors should not exceed 6-8 cycles. Options A, C, and D may be issues, but not as critical or damaging. Question 9. To what extent does psychrometric analysis assist in diagnosing issues in a dehumidification-focused HVAC system serving a museum archive space? A. It helps identify latent and sensible loads during swing seasons. B. It reveals the carbon dioxide concentration affecting artifacts. C. It confirms whether the refrigeration cycle is running in subcooling. D. It pinpoints microbial growth through enthalpy deviation. Answer. Correct answer. A. Explanation. Psychrometric charts allow calculation of dew point, RH, and load splits essential in humidity critical spaces like archives. A CAT manual P and ASHRAE 55 support its use. CO. B. And microbial issues D require separate testing, and subcooling C relates to refrigerant performance, not air conditions directly. Question 10. Upon closer examination of an advanced DEC control system, Mr. Bradley notices that certain temperature sensors report inconsistent values compared to verified field measurements. What is the most appropriate supervisory level action to ensure long-term reliability? A. Replace the sensors and recalibrate the control system. B. Adjust the controller logic to accept the new baseline. C. Isolate the sensor wires and perform a continuity test. D. Review the calibration schedule and implement periodic validation. Answer. Correct answer. D. Explanation. Sensor drift is common in DEC systems over time. Establishing a calibration verification program aligns with ASHRAE GPC 20 and ISO 9001 quality protocols. Options A and C are reactive. B. Risks accepting inaccurate data. Periodic validation ensures accuracy and system control integrity. Question 11. During the process of overseeing a chiller plant optimization project, Hawthorne realizes that the chilled water delta T consistently underperforms during low load periods. Which control strategy adjustment would most effectively enhance system performance and reduce energy waste? A. Reduce the condenser water set point by 5 degrees. B. Modify the chilled water reset schedule based on outdoor air temperature. C. Implement differential pressure setpoint reset strategy for chilled water pumps. D. Increase the design flow rate through variable frequency drives. Answer. Correct answer. C. Explanation. Resetting the differential pressure setpoint based on actual demand avoids overpumping, improving part load efficiency. ASHRAE Guideline 36 and DOE's energy optimization protocols endorse this strategy. Resetting temperature B and reducing condenser water temp A have secondary impact, while increasing flow D worsens delta T issues. Question 12. Contrary to popular belief, what is the most likely consequence of oversizing a residential HVAC system even when it meets peak load conditions? A. The system will maintain better temperature stratification. B. Increased on-cycle duration enhances dehumidification. C. Equipment will operate at higher energy efficiency ratios. D. Short cycling leads to reduced comfort and humidity control. Answer. Correct answer. D. Explanation. Oversized units cycle frequently, failing to run long enough to remove humidity, leading to occupant discomfort and premature equipment wear. This contradicts the assumption that bigger is better. ACAP Manual S and ASHRAE Fundamentals recommend sizing based on calculated loads, not rule of thumb estimates. Question 13. When presented with inconsistent airflow readings that multiple valve boxes in a commercial HVAC system is to ATMED suspects a control logic issue. What is the most effective supervisory action to identify root cause without disrupting operations? A. Perform a full duct leak test across all valve branches. B. Rebalance the entire system manually. C. Review trend logs from the building automation system BAS. D. Replace all valve airflow sensors. Answer. Correct answer. C. Explanation. Reviewing BAS trend logs allows non-invasive analysis of past performance, identifying logic errors, control drift, or sensor failures. ASHRAE 135 BACnet supports this as a best practice. Full duct testing and sensor replacement. D. Time-consuming and may not be necessary. Manual rebalance. B. Treats the symptom. Question 14. A critical examination of a hospital's HVAC system reveals temperature swings in operating rooms despite system redundancy. Which of the following is the most plausible root cause? A. Oversized humidifiers in air handling units. B. Improperly sequenced control strategies between redundant units. C. High velocity airflow from linear diffusers. D. Faulty economizer damper linkages. Answer. Correct answer. B. Explanation. Control sequence misalignment between redundant AHAs can cause both units to overreact, leading to hunting and temperature swings. ASHRAE 170 and Facility Guidelines Institute FGI standards require precise control coordination in healthcare environments. Humidifiers, A. Diffuser velocity, C. And dampers, D. Are secondary contributors. Question 15. Taking into account the principles of refrigeration cycle design, which of the following will most likely increase the efficiency of a system during part load conditions? A. Operating the expansion valve in a fully open position. B. Subcooling the liquid refrigerant before expansion. C. Introducing hot gas bypass for compressor protection. D. Increasing suction line insulation thickness. Answer. Correct answer. B. Explanation. Subcooling improves system COP by maximizing refrigerant effect per unit mass, especially during partial load. ASHRAE guidelines note that proper subcooling raises evaporator efficiency. Hot gas bypass. C. Increases energy use. Expansion valve. A. Should modulate, not stay open. Suction insulation. D. Aids marginally. Question 16. The impact of advanced controls in ERF systems becomes particularly evident under which condition? A. When compressor cycling frequency reaches a minimum. B. When simultaneous heating and cooling zones are served by one outdoor unit. C. When the system operates with 100% outside air. D. When refrigerant charge is intentionally reduced for staging. Answer. Correct answer. B. Explanation. ERF systems excel in mixed-mode conditions, using advanced logic to redistribute heat internally, improving efficiency. ASHRAE 15 and manufacturer documentation outline this benefit. Options A and C involve efficiency but not unique ERF capabilities. Reduced charge. D. Violate safe operational standards. Question 17. In light of recent developments in refrigerant regulation, what is the most appropriate refrigerant selection consideration when designing a commercial system projected to operate through 2035? A. Choose a refrigerant with the lowest latent heat of vaporization. B. Select a refrigerant with high volumetric efficiency. C. Prioritize DDWN ASHRAE safety classification. D. Use hydrocarbon-based refrigerants to future-proof the system. Answer. Correct answer. C. Explanation. WN safety classification ensure compliance with Kigali Amendment APAT SNAP and emerging climate regulations. Efficiency. B is important but secondary. Hydrocarbons. D are flammable and often restricted in commercial applications. Latent heat. A does not address regulatory risk. Question 18. From a historical standpoint, why did early pneumatic control systems in HVACR fall out of favor despite their reliability? A. They lacked the ability to control pressure in hydronic systems. B. Energy consumption was higher than modern DDC systems. C. Limited scalability and poor integration with digital systems. D. They used mercury switches, which became illegal. Answer. Correct answer. C. Explanation. Pneumatic systems struggled with integration into digital bus networks and lacked remote diagnostics or programmability. As systems grew, DDC replaced pneumatics for flexibility and data management. ASHRAE GPC 13 outlines the transition. DEC. Mercury. D was phased out but not the primary reason. Question 19. Based on the information provided by a recent energy audit, a commercial refrigeration system using R404 shows excessive compressor runtime. What supervisory level corrective action should be considered first? A. Schedule compressor oil changes more frequently. B. Reprogram the defrost cycle duration and frequency. C. Replace all evaporator fans with ECM models. D. Adjust XP superheat settings to increase capacity. Answer. Correct answer. B. Explanation. Excessive or poorly timed defrost cycles cause unnecessary compressor runtime and energy waste. Though refrigeration efficiency standards and manufacturer specs recommend defrost cycle optimization, ECM fans C and oil changes A help but don't address root cause. TXV adjustments D may not yield results if defrost is inefficient. Question 20. What factors contribute to poor performance in a chilled beam system used in a high-humidity coastal environment? A. The use of low-velocity air handling. B. The absence of terminal repeat coils. C. The lack of humidity control leading to condensation. D. The system's inability to recirculate air. Answer. Correct answer. C. Explanation. Chilled beams operate near dew point. Uncontrolled humidity leads to condensation risk, violating ASHRAE 62.1 and 55 conf safety requirements. Dehumidification is critical before air enters the zone. Terminal reheat. B. And recirculation. D. Are system-specific, but condensation due to RH is the critical issue. Question 21. The correlation between system reliability and compressor lubrication in large commercial chillers becomes critical under which of the following circumstances? A. When suction line pressure is below atmospheric pressure. B. When the oil separator is improperly sized for the system. C. When ambient temperature falls below the chiller's minimum operating range. D. When the condenser fan cycles too frequently. Answer. Correct answer. B. Explanation. Improperly sized oil separators fail to remove oil mist effectively, reducing lubrication in the compressor, leading to wear or failure. ASHRAE Handbook. Refrigeration stresses proper oil management for reliable long-term operation. Suction pressure A and ambient temp C are factors, but not directly tied to lubrication. Frequent fan cycling D affects head pressure, not lubrication. Question 22. According to recent studies in energy efficiency, what is the most effective way to reduce energy consumption in a commercial HVAC system without altering the mechanical configuration? A. Switching to oversized return ducts. B. Installing variable frequency drives VFDS on fan motors. C. Running all air handling units at full capacity during occupied hours. D. Eliminating economizer cycles during shoulder seasons. Answer. Correct answer. B. Explanation. Installing VFDS allows fan speeds to adjust based on load, significantly reducing power consumption. Cube Law, Dern, ASHRAE 90.1 standards endorse VFDS at a primary retrofit strategy. Oversized ducts, they are helpful but don't actively reduce energy. Full capacity, C, and removing economizers, D, are wasteful strategies. Question 23. In what ways can poor documentation practices by HVACR supervisors impact system performance over time? A. They increase the service life of refrigerant recovery equipment. B. They help improve mechanical inspection turnaround time. C. They hinder preventive maintenance planning and diagnostics. D. They increase airflow at terminal registers. Answer. Correct answer. C. Explanation. Lack of documentation leads to missed service histories, incorrect system settings, and inefficient troubleshooting, or reducing performance. NFPA 7 and EPA 608 stress the importance of records for safety and compliance. The other options are either unrelated or factually incorrect. Question 24. When faced with duct leakage discovered during commissioning of a high-rise building, Mr. Langley is advised to use pressure testing to quantify the extent. What standard should guide the acceptable leakage criteria? A. ASHRAE 90.2 Residential Energy Standard. B. ACAM Manual. D. C. SMACNA HVACR Duct Leakage Test Manual. D. National Mechanical Code. Answer. Correct answer. C. Explanation. SMACNA's leakage test manual specifies allowable leakage rates and testing procedures for commercial systems. ASHRAE 90.2A applies to residential, and ACAM Manual D. B is residential duct sizing. National Mechanical Code D is broad and doesn't specify leakage testing. Question 25. The general consensus is that a significant limitation of using hot gas BIPTISHIP in a refrigeration system is that it A. decreases suction superheat and causes flooding, B. increases head pressure and reduces condenser efficiency, C. reduces part load energy efficiency, D. causes excessive subcooling in the receiver. Answer. Correct answer. C. Explanation. AEP maintains evaporator pressure at low load but does so by sacrificing energy efficiency, essentially wasting compressor capacity. Per RA and DO efficiency standards, this method should be used cautiously. Superheat A, head pressure B, and subcooling D may be affected but are not the key drawback. Question 26. A key distinction between cooling tower designs is whether they are open circuit or closed circuit systems. What is the major operational difference between the two? A. Open towers use glycol while closed towers use water. B. Closed circuit towers require chemical treatment more frequently. C. Closed circuit towers prevent process fluid from contacting outside air. D. Open towers operate at lower condensing temperatures. Answer. Correct answer. C. Explanation. Closed circuit cooling towers keep process fluid in sealed coils, isolating it from ambient air and reducing contamination risk. The ASHRAE 202 and CTI guidelines outline these distinctions. Glycolate may be used in either. The chemical frequency, B, depends on water quality. Temperature differences, D, vary by load and design. Question 27. Scholars have debated whether high system static pressure directly causes valve box damper failure. What is a more likely result of prolonged high static pressure in a duct system? A. Accelerated wear of the supply fan motor. B. Reduced air changes per hour. C. Poor economizer logic response. D. Constant volume operation of valve boxes. Answer. Correct answer. A. Explanation. Sustained high static pressure increases the load on the supply fan motor, raising amperage draw and reducing its lifespan. ASHRAE 90.1 and SMACNA design guidelines emphasize balancing airflow to prevent excessive static. HB is more dependent on total airflow. Economizer logic, C, is unrelated. Valves don't shift to constant volume mode from pressure alone. Question 20. Among the various diagnostic tools available to HVACR supervisors, why is thermal imaging considered vital during a scheduled maintenance check? A. It measures refrigerant levels non-invasively. B. It identifies latent heat loads in airstreams. C. It visualizes temperature differences indicating failing components. D. It detects vibration frequency in motors. Answer. Correct answer. C. Explanation. Thermal imaging detects abnormal heat signatures in motors, breakers, compressors, and ducts, helping catch faults early. NFPA 7-tib and predictive maintenance best practices support thermal scanning as a proactive tool. It cannot directly measure refrigerant A, latent heat B, or vibrations D. Question 29. Based on the information gathered during a system retrofit audit, a technician proposes relocating a rooftop unit's outdoor air intake from parking garage wall to the roof edge. What critical factor is being addressed? A. Load shedding priority compliance. B. Mitigation of exhaust gas recirculation into occupied spaces. C. Maximizing nighttime ventilation rates. D. Preventing compressor short cycling from radiant heat. Answer. Correct answer. B. Explanation. Drawing outdoor air from near parking garages risks contamination by vehicle exhaust. Per ASHRAE 62.1 and local building codes, intakes must be located away from pollution sources to protect VAC. Other answers may be secondary benefits but not the main issue. Question 30. To determine whether duct static pressure reset control is functioning properly, what parameters should be monitored over time in a valve system? A. Compressor suction pressure trend. B. Supply fan current draw versus demand. C. Return air temperature fluctuations. D. Discharge air humidity level. Answer. Correct answer. B. Explanation. Static pressure reset aims to reduce fan speed when demand drops. Monitoring supply fan amperage AW versus valve box demand indicates if the reset strategy is working. An ASHRAE guideline 36 supports this as a best practice. Suction pressure A, return temp C, and humidity D do not directly relate to duct pressure reset.